Hello everyone, we are back with another video on unit and measurement, which is part 2. In this video, we will discuss derived physical quantities and their SI units. So first quantity is area. The formula for area is length into breadth and its unit is meter square. Next is volume. Formula for volume is area into height. Unit for area is meter square when it is multiplied with the meter and its unit becomes meter cube. Next quantity is velocity. Formula for velocity is displacement upon time. Unit for displacement is meter and unit for time is second. So unit becomes meter per second. Next quantity is acceleration. Formula is velocity upon time. Unit for velocity is meter per second and when it is divided by second, its unit becomes meter per second square. Next quantity is force. Formula is mass into acceleration. Unit for mass is kilogram and unit for acceleration is meter per second square. So the unit of force becomes kg meter per second square. The other unit for force is Newton. So kg meter per second square is equals to Newton. Next physical quantity is angular velocity. Formula is angular displacement upon time. Angular displacement is angle described by a rotating body from one position to the another as it is an angle, and we know that plane angle is fundamental quantity and its SI unit is radian. So unit for angular velocity is radian per second. Next quantity is angular acceleration. Formula is angular velocity upon time and unit for angular velocity is radian per second, and when it is divided by time, its unit becomes radian per second square. Next quantity is density. Formula is mass upon volume. Unit for mass is kilogram and unit for volume is meter cube. So unit of density becomes kg per meter cube. Next quantity is momentum. Formula is mass into velocity. Unit for mass is kilogram and unit for velocity is meter per second. So the unit of momentum becomes kg meter per second. Next quantity is moment of inertia. Its formula is mass into distance square. Unit for mass is kilogram and unit for distance is meter. So unit of inertia becomes kg meter square. Next quantity is pressure and stress, both having same units, and formula is force upon area. In previous slide, we discussed the unit for force, which is kg meter per second square, and when it is divided by area, its unit becomes kg per meter per second square. We know that other unit of force is Newton and unit for area is meter square. So other unit for pressure becomes Newton per meter square, which is equals to Pascal. Next physical quantity is work or energy, both having same units, and formula is force into distance. When kg meter per second square is multiplied with the distance, its unit becomes kg meter square per second square. Other unit for force is Newton and distance is meter. So the other unit for energy is Newton meter, which is equals to joule. Next quantity is impulse. Formula is force into time. And when kg meter per second square is multiplied by time, its unit becomes kg meter per second and other unit is Newton second. Next physical quantity is surface tension. The formula is force upon length. When kg meter per second square is divided by length, its units becomes kg per second square and other unit becomes Newton per meter. The next quantity is moment of force, which is also called as torque, and formula for torque is force into perpendicular distance, and when kg meter per second square is multiplied by distance, its unit becomes kg meter square per second square and other unit becomes Newton meter. We have noticed that work, energy and torque having same units. Next physical quantity is power. Formula is work upon time. In previous slide, we have discussed that unit for work is kilogram meter square per second square, and when it is divided by time, its unit becomes kg meter square per second cube, which is equals to watt. Next quantity is charge, and formula for charge is current into time. In a previous video, we have discussed that electric current is a fundamental quantity and whose SI unit is ampere. So the unit for charge is ampere second and other unit is coulomb. Next quantity is surface tension. The formula for surface tension is force upon length. Unit for force is kg meter per second square, and when it is divided by length, unit becomes kg per second square and other unit becomes newton per meter. Next quantity is impulse. Formula is force into time, and when force is multiplied by time, its unit becomes kg meter per second and other unit becomes newton second. Next quantity is frequency. Frequency is reciprocal of time period and unit for time is second. So the unit of frequency is second inverse and other unit is hertz. In this video, we will also discuss some of the rules and conventions for writing SI units and their symbol. When the unit of any physical quantity is written after the name of a scientist, it should be written with the small letters. As we write Newton as a unit of force, then we have to write Newton with the small initial letter. Second rule is the symbol of units named after the scientist should be written by capital letter, and when we use symbol as a unit after the name of a scientist, then we use capital letter. When we had to write N for Newton, then N should be written in a capital letter, and when we have to write H for Henry, then H should be written in a capital letter. Similarly, when we had to use W for watt, then W should be written in a capital letter. Now next rule is small letters are used as a symbol for units not derived from the proper name. For those physical quantity whose units are not derived from the proper name should be written with the small letters. For example, when we use M for meter, then M should be written with the small letters. When we use kg for kilogram, then kg should be written in a small letters. When we use S for second, then S should be written in a small letters. Next is no full stop or punctuation mark should be used within or at the end of a symbol. When we had to write the measurement of any physical quantity, then we write it 50 m. We need not to put any punctuation mark at the end of the measurement. The symbol of a unit do not take plural form. We need not to write 10 kgs. We can write only 10 kg. Next is when temperature is expressed in a Kelvin, the degree sign is omitted. We need not to write 273 degree Kelvin. We had to write 273 Kelvin only. But when we have to express the temperature in a Celsius, we had to include the degree sign. We had to write 100 degree Celsius. Next rule is use of solidus is recommended only for indicating a division of one letter unit symbol by another unit symbol. Not more than one solidus is used, as we have given in an example at the last, that is joule per Kelvin per mole. We need not to put the solidus sign again and again. Next is some space is always to be left between the number and the symbol of a unit and also between the symbol of a compound unit such as force, momentum, etc. As we have written in example, when we had to write 2.3 meter, then we have to put a space between 2.3 and a meter. Next is only accepted symbols should be used. We have to use A for ampere, not AMP or AM. When we have to use symbol for second, we have to use S, not as SEC. Next is numerical value of any physical quantity should be expressed in a scientific notation. For example, when we had to write the density of a mercury, we need to write it 1.3 into 10 raised to the power of 4 kg per meter cube, not as 13,600 kg per meter cube. So that's all about for today. Hope you like today's learning session. Thank you so much. If you like, then please like, share and subscribe the channel. Thank you.